I find myself in a rather curious place. I'm on the southern outskirts of Death Valley National Park in the Mojave Desert of Southern California. Now, this is one of my favorite localities because it records a really interesting portion of Earth's history that most people don't know about and wouldn't expect. Behind me is the roughly 700 million year old Kingston Peak Formation. Now, there's no better way to talk about geology than to get on the actual rocks, so let's go take a look. So the Kingston Peak Formation is a collection of sedimentary layers with very poorly sorted grains. You have everything in here from pebbles to cobbles and even boulders. Now, this is what's called a diamictite, and this one in particular is a glacial diamictite. As glaciers move, they pick up sediments and deposit them when they melt in something called a glacial till, which is what it's called before it becomes cemented together like this, or lithified. See, it's all cemented together in a very iron-rich clay or mud, giving it that reddish color. That's how you get massive boulders sitting in the middle of the mud like this one. This is called a glacial dropstone, and it's another piece of evidence that you had glaciers advancing. As the glaciers move, they pick up these boulders and carry them out to the middle of the ocean and just drop them as the ice melts. Here you can see the layers of mud that got compressed when the boulder landed. This is a big piece of limestone, and these holes drilled here, I'm assuming, are for cores that people probably collected for testing. It's pretty interesting stuff. So these muds contain grains of magnetic material, and their orientation is locked in at the time of deposition. So scientists were able to measure that relative to where the North Pole was at the time, and they found that these were actually deposited around the equator. That's because during this time, Laurentia, or the North American craton, which makes up the core of North America, was hovering around the equator next to the supercontinent Rodinia. So you're probably wondering, how do we have glaciers and glacial deposition in one of the hottest places on the planet at the furthest point from the poles? And that's because it wasn't always the hottest place on the planet. The Earth was going through a really interesting time in its history where it was completely covered in ice in what is now referred to as snowball Earth. So it went through two pretty massive glaciation events in rapid succession that collectively lasted a little under 100 million years, from 720 to 635 million years ago, in what is now called the Cryogenian. Though recent arguments suggest that the ice around the equator may have been broken up or just very thin, otherwise photosynthetic life would have struggled to survive. But it's also speculated that if the Earth was covered in a layer of solid ice, that life may have been able to persist around deep sea hydrothermal vents. So you can see, looking at the Kingston Peak Formation, the layers change in pretty rapid succession back and forth from fine to coarse to fine again, in layers that, geologically speaking, are pretty thin. So this is evidence that the water levels were changing as well as glaciers melted and refroze. So things were still flowing. So you have a few reasons that glacial periods can happen. You have greenhouse gases being trapped in erosional material, an increase in oxygen levels, changes in the ocean's current due to continental drift, or something called the Milankovitch cycle, which is a variation in the shape of Earth's orbit as it's pulled back and forth between the other planets, the increase or decrease in the Earth's tilt, or how much the Earth wobbles. So the Earth wobbles because it isn't a perfect sphere. It actually bulges around the equator. So all of this changes the amount of sunlight that's able to reach the poles, which in turn makes them colder, which makes more ice grow, which increases the pole's albedo, which is the reflectivity. And as the poles get colder, more ice grows, and it just causes a positive feedback loop in what's called a runaway icehouse effect. So you potentially have all of these things happening at just the right time to cool the planet enough to completely cover it in ice. So how did we escape this massive ball of ice? Well, the ice wasn't strong enough to keep plate tectonics from happening, so the breakup of Rodinia didn't stop. And as it broke up, we had an intense increase in volcanic activity, which increased the amount of greenhouse gases like carbon dioxide and methane that were released into the atmosphere. Eventually, this built up enough for it to warm the planet, and the ice started to melt. You can see as I walk, the layers start to become more fine and a bit shaly. You still have some drop stones. There's one there. This is what's called a transgressive sequence, or fining upwards. And this is what happens as water levels rise, because the glaciers were melting. So I'm actually walking into younger and younger rocks right now. So as the glaciers melted, populations of photosynthetic organisms like cyanobacteria and algae just boomed due to the increased sunlight. And as they died, they sank to the bottom and formed these layers of calcium carbonate, which eventually lithified into limestone. You can see here, these are actually fossils of algal mats or stromatolites. So the limestone later on reacted with magnesium-rich water, presumably from erosion, and actually went through a process called diagenesis, in which a calcium ion is replaced with magnesium to form something called dolomite. And these are the same type of rocks that are in the Dolomites in Italy. This formation is called the Noonday Dolomite, and it sits on top of the Kingston Peak Formation. You can see I'm actually standing on the contact between the Kingston Peak and the Noonday, and it marks the end of the Cryogenian and the start of the Ediacaran. You can see the contact over there between the Noonday and the Kingston Peak is offset a little bit, presumably due to the subsequent faulting that occurred in the area. Well, that's all I have for you today. I hope you enjoyed, maybe learned something, and as always, take care.